So this video is about vectors in three-dimensional space. When I'm talking about three-dimensional space, I'm talking about x, y and z. So our xy plane has now been flipped and we're including the third dimension. So some point out in space, here's our point A. It will have an x, a y and a z coordinate. One in the x direction, one in the y direction, one in the z direction. You'll notice that the x, y and z are all at right angles. The axes are all at right angles to each other. So the vector from O to A is that vector there from the origin to A. And it's going to be in terms of x, y and z. Let's have a look at an example. Here's a point which is at the point 4, minus 2 and 3. Find the vector OP and the magnitude of OP. So the vector OP, it's going to be 4i, 4i plus, take that back, minus 2j plus 3k, where k, we've already met I and j, k is a unit vector in the z direction, vector in z direction. Now we want to find the magnitude of that. So there's our vector. OP is 4i minus 2j plus 3k. The magnitude, we're still using Pythagoras here, is the square root of 4 squared plus 2 squared plus 3 squared. Remember, it's positive. The magnitudes don't, when we're working out the magnitude, the positives and negatives don't matter, because when we square minus 2, it becomes plus 2. So that gives us 16 plus 4 plus 9. Let's add all of that together, and that gives us 29. Square root of 29. So there's the magnitude of OP. Now let's have a look at another point. What if we want to find a vector in space, a direction vector that goes from one point to another point? And I've got x1, y1, z1 as my A, and x2, y2, z2 as my B point. So remember, A to B is the position vector of B minus the position vector of A, minus the position vector of A. So in this case, that's x2i plus y2j plus z2k. That's my position vector of B, and I'm subtracting x1i plus y1j plus z1k. Remembering my tildes for the vectors, well, x, that becomes x2 minus x1 times I, y2 minus y1 times j, and z2 minus z1 times k. So that's our general rule for finding the position vector in three-dimensional space. Let's apply that to an actual problem. A is the point 1, 4 and minus 3, x, y and z. B is the point 5, minus 2 and 6. Let's find AB, vector AB. Let's do that now. So AB is going to be 5 minus 1 times I plus minus 2 minus 4 times j plus 6 minus minus 3 times k. What does that give me? 4i minus 6j, and minus and minus becomes a plus, 9k. Now there's my vector from A to B in three-dimensional space. Let's find the magnitude of that vector. The magnitude of that vector is the square root of 4 squared plus 6 squared plus 9 squared. Which, what does all that add up to? 16 plus 36 plus 81, maybe that's 133. So the magnitude of that vector is 133. So this little video has been about finding the vector in three-dimensional space and finding its magnitude.